గ్రాఫ్ ని adjacency matrix లో ఎలాగా రిప్రజెంట్ చేస్తాము, అన్డైరెక్టెడ్ గ్రాఫ్ ని కూడా adjacency matrix లో ఎలా రిప్రజెంట్ చేస్తాము అనేది ఇవాళ టాపిక్. ఓకే, ఇవాళ అంతా కూడా adjacency matrix తోటే ఉంటుంది. సో టుమారో క్లాస్ adjacency list. Okay, so the matrix, so everyone you know what is a matrix. So a matrix is nothing but so the elements are organized in the combination of rows and columns. Okay, that is called the matrix. Okay, here also the graph can be, here also we represent the graph by using adjacency matrix. For example, you see, okay, this is one graph, undirected graph. This is undirected graph. This is undirected graph. Okay, na? I am not showing any directions. This is undirected graph. So the vertex is A, the vertex is B, this is the vertex B. So this is vertex C, this is the vertex D, this is the vertex E. So this is the undirected graph. How this undirected graph is represented by using adjacency matrix. First, you count the number of vertices in the graph. Okay, how many vertices you have? There are 5 vertices. Okay, so you take the 5 by 5 vertices. So the first point in the adjacency matrix is, first you count the number of vertices in the graph. So in this graph there are 5 vertices, so that I am taking the 5 by 5 matrix. You take the 5 by 5 matrix. So this is the not 5 by 5 matrix, this is the 6 by 6 matrix. So why I am taking 6 by 6? One row and one column can be, I reserved one column, one row for particularly representing the labels of vertices. Okay, so the vertices, what are the vertices? A is one, the A is one vertices, B, C, D and E. Okay, there are 5 vertices in a row and the 5 vertices in a column. Okay, you have to take like this. You have to take like this. So the size of the rest of the box is 5 by 5. Okay, this is 5 by 5. There are 5 rows and 5 columns. Okay, so here, so how the graph is represented in the graph in the matrices means, you see there is a path. You see there is a path from A to B. There is a path from A to B. అంటే A నుండి B కి పాత్ ఉంది కదమ్మా. సో ఇక్కడ ఇది A, ఇది source. All these are called the sources. All these are called the destinations. Okay, so ఇవన్నీ ఏంటని చెప్తున్నాను నేను? సోర్స్ వెర్టిసెస్. ఇవన్నీ ఏమని చెప్తున్నాను నేను? డెస్టినేషన్ వెర్టిసెస్. ఓకే, హియర్ హూ ఇస్ ద సోర్స్ అంటే ఎక్కడి నుంచి ప్రయాణం స్టార్ట్ చేస్తాం. సో ద సోర్స్ ఈజ్ ఏ, ద డెస్టినేషన్ ఈజ్ బి. అంటే సోర్స్ అంటే ఇదే కదా ఏ, డెస్టినేషన్ ఎంత బి. అంటే then you have to write 1. If the route is having from source to destination, you have to put 1 in the position. Okay, so then you take the A to C is also one connection, then source is A, the C is also, you have a direction, you have a link. And is any connection from A? Is any connection from A? No. Okay, so that The A to A is no connection 0. A to D there is no connection 0. A to E there is no connection 0. Then you take the next source is B. So you take the B. The A is over. A is over. You take the B. There is a path from B to A, and B is the source, A is the destination. Then 1. There is a path from B to B. B నుంచి B కి ఏమైనా రూట్ ఉందా? No. Then you put the 0. Then B to C there is a path. So that you have to write 1. There is a B to D is also one connection. Then you put 1. B to E there is no direct connection. There is no direct connection. Then you have to write 0. You put 1 if there is an edge, if there is a direct edge from source to destination. Otherwise you have to write 0. Okay. Then you take the another source C. So there is a path from C to A. There is a path from C to A. There is a path from C to B. There is a path from C to D. There is C to C. There is no path. There is no path from C to C. There is a C to D. There is a path, and C to E is also one path. And the next source is D. Okay. So is there any edge from D to A? No. So that you have to put 0. Is there any edge from D to B? Yes. Then you have to put 1. Is there any route from D to C? Yes, there is a route. Put 1. Okay. So is there any route from D to D? No, that is 0. Is there any route from D to E? No, put 0. Okay, finally the last source is E. E to A there is no route. E to B there is no route. E to C there is a route. E to D there is no route. E to E there is no route. So this is called how the graph is represented, how the undirected graph, not directed graph, undirected graph representation using the adjacency matrix, Class lecture. The first one, you take the source A to B, there is a connection. A to B, there is a connection. There is a route, there is a edge from A to B. Then I am giving 1. A to A, 0. A to A, 0. A to B, that is, yes, there is a direct edge, 1. A to C, there is no edge. A to D and A to E also, there is no direct edge. Then all are 0. So, the next one is B to A. No, there is no direct edge, 0. So B to C, B to B, there is no edge. B to C, yes, there is the edge. B to E, B to D is also direct edge. B to E, there is no edge. And the one more is the C. The C to A, there is an edge. C to B, no edge. C to D, no edge. C to C, no edge. C to D, no edge. And C to E, there is an edge. Then coming to D. D to A, there is no edge. D to B, no edge. D to C, there is an edge. D to D, there is no edge. D to E, there is no edge. So then E, you take the E. There is no path from E to A, E to B, E to C, E to D, and E to E. Here coming to big question of travel. Why you are using the adjacency matrix? Okay, why you are using adjacency matrix for representing the graphs? And then once the graph is converted into the adjacency matrix by using this matrices, so where the number of zeros, the matrix is the Boolean matrix. The entries in the matrix can be either 0 or 1 only. If the matrix having number of zeros, so you can convert that matrix into sparse matrix. Then you can easily analyze that sparse matrix. The sparse matrix can take the less space than the original matrix. If there are so many zeros are there in the matrices, the space is waste. Okay, so once the original matrices are constructed, if the number of zeros, if the matrix having the number of zeros, so this matrix can be converted into sparse matrix. That sparse matrix can be very easy to analyze the graph. That's where the one of the important conversion from graph is adjacency matrix. So there are two kinds of graph representations: adjacency matrix and adjacency list. What is adjacency matrix? An adjacency matrix is a way of representing graph as a matrix of Boolean. ఇలా చెప్పాను కదా, adjacency matrix లో adjacency matrix ని Boolean matrix గా రిప్రజెంట్ చేస్తాం. ప్రతి ఎంట్రీ కూడా 0 గాని 1 గాని ఉంటుంది. ఓకే, there is an edge from source to destination 1. There is no edge from source to destination to represent that edge by 0. So ఎప్పుడైతే మన దగ్గర గ్రాఫ్ ఉందో, you have to count the number of vertices in that graph. ఆ గ్రాఫ్ లో ఎన్ని వెర్టిసెస్ ఉన్నాయో కౌంట్ చేసుకోవాలి. కౌంట్ చేసుకుని అన్ని వెర్టిసెస్ కి n by n adjacency matrix క్రియేట్ చేసుకోవాలి. You have to create n by n adjacency matrix for the graph. So that is n by n dimension. Next ఏం చెప్తున్నాం? If there is an edge from vertex I to j, ith vertex నుంచి jth vertex కి there is an edge, then the adjacency matrix of ij, ith column, ith row and ith column is marked as 1. Okay na? If there is no edge from vertex I to j, mark adjacency matrix of ij is 1, 0. ఓకే, ఇక్కడ చూడండి అమ్మా, నేను ఇదేమంటున్నాను, ద ఫస్ట్ రో, సెకండ్ రో, థర్డ్ రో, ఫోర్త్ రో, ఫిఫ్త్ రో, అండ్ ఫస్ట్ కాలమ్, సెకండ్ కాలమ్, థర్డ్ కాలమ్, ఫోర్త్ కాలమ్ అండ్ ఫిఫ్త్ కాలమ్. ఓకే, ఎన్ని వెర్టిసెస్ ఉంటే అన్ని రోస్ అండ్ కాలమ్స్. ఇక్కడ ఏం చెప్తున్నాను, ఫర్ ఎగ్జాంపుల్ ఇది ఫస్ట్ నోడ్, ఇది సెకండ్ నోడ్ అనుకున్నాం. ఈజ్ దేర్ ఎనీ పాత్ ఫ్రమ్ ఫస్ట్ నోడ్ టు సెకండ్ నోడ్? ఎస్ అనుకో, ఏమంటున్నాను, ఫస్ట్ రోలో సెకండ్ కాలమ్ అంటే మ్యాట్రిక్స్ అంటే adjacency matrix of 1 2 అంటే this is the 1 2. okay, that is marked as 1. So that is the way. So you can represent the adjacency matrix. If there is no edge from vertex I to j, then mark the ith row and jth column as 0. So there is one example. There is ABC graph is there. This is example of adjacency matrix of the given graph already. So it has explained. Okay, the next one, the representation of directed graph using adjacency matrix. Okay, So this is the representation of directed graph. Directed graph adjacency matrix. Adjacency matrix for directed. So adjacency list is the tomorrow's topic. Adjacency list is the